Hello, I'm Toro, and this is the Great Blunders. Every great civilization, every genius plan, every bold idea has its moments of unexpected failure. In this series, we gently explore the missteps, mistakes, and strange decisions that changed history, softly told, one blunder at a time. There's no drama here, just quiet hindsight, calm reflection, and a little curiosity. So settle in, breathe deep, and let's revisit a moment when the world didn't quite go as planned. Hello, my friend. It's Toro, and tonight I invite you to join me in the quiet space, between wakefulness and sleep, where stories drift as slowly as falling snow, and history folds itself into soft, dreamlike shapes. In this series, The Great Blunders, we'll look not at triumphs alone, but at the moments when human plans went gently, unexpectedly astray, not with judgment and not with sharp edges, but with the calm understanding that mistakes are threads woven through the grand tapestry of our journey. Every great endeavor, whether it is a bridge across a river, a voyage across an ocean, or a spacecraft slipping between planets, carries within it both our brilliance and our capacity to overlook the small. And so, as the night leans in, and the world outside your window settles into its own slow breathing, let's drift back to 1999, to the edge of the solar system's red desert, into a delicate visitor called the Mars Climate Orbiter, a spacecraft that traveled millions of miles, only to vanish into silence because of a mismatch in the language of numbers. The late 1990s were a bridge between centuries, a time when we could still feel the hum of the 20th century's machines. And yet, just ahead, the promise of the new millennium shimmered, like light on distant water. The internet was still an unfamiliar frontier, a place of dial-up tones and simple pages, where the world was only beginning to braid itself together in digital threads. Mobile phones were slimmer than before, but they had not yet learned to carry whole worlds in their screens. In the midst of this changing Earth, humanity's gaze turned upward and outward. Mars, that rust-colored ember in the night sky, had been a fascination for centuries. It had inspired myths, sparked science fiction dreams, and teased astronomers with hints of dry riverbeds and polar caps. For NASA in the late 90s, Mars was not a distant fantasy. It was a next step. The space agency had embraced a philosophy they called faster, better, cheaper, instead of pouring enormous sums into a few giant missions. They would send more frequent, smaller spacecraft, nimble explorers, each with a focused purpose. The Mars Climate Orbiter was one such traveler. It would weigh less than 340 kilograms, lighter than a grand piano, and would slip into orbit around Mars to watch the planet's atmosphere and climate with quiet precision. Its instruments would measure temperatures, dust storms, water vapor, and the faint winds that curled through its thin air. It would even serve as a communications link for another mission soon to follow, the Mars Polar Lander. The journey to Mars would take about 9 months. The orbiter would be launched from Cape Canaveral, ride a Delta II rocket into the blue morning sky, and then glide into the great silence between planets. It was a time of optimism. After all, this was not humanity's first trip to Mars. We had sent landers, orbiters, and probes before. We knew the way, or so it seemed. And so, in December of 1998, when the rocket engines lit and the Mars Climate Orbiter began its climb, there was joy in the control rooms. The spacecraft separated cleanly, unfurled its solar panels, and began its long, steady drift. The months that followed were calm. From millions of kilometers away, the spacecraft spoke to Earth in a patient stream of numbers and signals. The teams at NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, watched over it carefully, adjusting its course with small engine burns, like a sailor trimming the sails, to keep a ship on the perfect heading. Each burn was measured, recorded, and sent along for navigation calculations. It was routine work, reassuring in its steadiness. But somewhere in those numbers, a small difference, too small to see at first, was quietly taking root. September 23, 1999. The date had been marked in calendars for months. It was the day the Mars Climate Orbiter would finally arrive at its destination. The plan was elegant and delicate. The spacecraft would approach Mars at high speed, then fire its main engine in a precise burn, to slow itself just enough to be captured by the planet's gravity. It would skim close, but not too close, to the thin atmosphere, close enough that, over the next weeks, it could use a process called aerobraking, dipping repeatedly into the upper atmosphere, to gently slow its orbit, like a hand trailing in water, slowing the drift of a boat. Every part of this plan depended on knowing exactly where the spacecraft was and how fast it was moving. Here, the threads of the story lead us back many months to those small course corrections made during the cruise to Mars. The spacecraft's thrusters were used for these adjustments. Each burst was tiny, measured in what engineers call impulse. The navigation team at JPL relied on numbers sent from Lockheed Martin, the company that had built the spacecraft, to know exactly how much each burn had changed the orbiter's speed and trajectory. And here, in the quiet language of units and numbers, was the seed of the blunder. Lockheed Martin software produced these impulse numbers in pound-force seconds, a unit from the old imperial system of measurement. But JPL's navigation software was expecting Newton seconds, the metric unit used in most of the scientific world. 1 pound-force second equals about 4.45 Newton seconds. The numbers looked fine on paper. There was no warning that the units were different, but in reality, each thruster burn was having more effect than JPL's calculations assumed. Over 9 months, the errors accumulated. The spacecraft's path shifted, just a little at a time, like a letter with a single wrong digit in its address, slowly wandering farther from its intended home. On the morning of September 23rd, no one knew the orbiter was already aimed for a much lower pass over Mars than planned. At 2:01 a.m. Pacific time, the spacecraft fired its main engine, disappearing behind Mars. As it swung around the far side, for several minutes, there would be no signal. This was expected. In the control room, engineers watched the countdown for its reappearance. The signal should return right on schedule. But it didn't. Seconds passed. Then minutes. A soft unease began to stir. The deep space antenna continued to listen, but the Mars Climate Orbiter never spoke again. Somewhere above the planet, it had dipped too low, likely into the upper reaches of the Martian atmosphere, where the thin air at orbital speeds was enough to tear it apart or send it tumbling into the surface. It had been traveling for 286 days, across 140 million kilometers, and was lost in the final moments of arrival. In the hours after the loss, the mission team combed through every scrap of data. The silence was final. There was no chance of recovery, but the why still had to be found. It did not take long for the mismatched units to emerge. One team had worked in pounds, the other in newtons, and no one had realized the numbers were speaking different dialects. The Mars Climate Orbiter had been intended to pass about 140 to 150 kilometers above the surface. Instead, it had likely swooped down to just 57 kilometers, deep enough that even Mars' whisper-thin atmosphere could end its flight. The news reached the public within days. Headlines mixed astonishment with a touch of disbelief. A $125 million mission lost because of a unit conversion error? For the people who had worked on it, it was not a punchline. It was a quiet grief. Years of effort, design, testing, and dreaming ended in a gap of silence from across the solar system. Yet from that silence came change. NASA's review board called for stricter verification processes, better communication between teams, and more robust checks for the most basic of details. In engineering and project management circles, the Mars Climate Orbiter became a textbook example of why clarity matters. It is still taught in classrooms today, not as a story of failure alone, but as a reminder of the thin line between perfect success and total loss. It is tempting, when hearing this story, to smile at the thought of spacecraft lost because of something as humble as a unit mismatch. But when we look closer, we see something deeply human. We see that communication, even among the most skilled teams, is a fragile thread. We see that assumptions, left unspoken, can drift unseen until the moment they matter most. We also see humility, even with decades of spaceflight experience and some of the most precise technology ever built. We are not immune to small errors. In fact, it is often the small ones that slip past the armor of our attention. The loss of the Mars Climate Orbiter reminds us that progress is not a straight road. It is a winding path with moments of triumph and moments when we must pause, look back, and learn. And so, though it never sent a single climate reading from Mars, the orbiter still left an imprint. Its story changed the way missions are planned and checked. It stands as a quiet beacon, one that says, even in our most ambitious journeys, it is worth slowing down to make sure we truly understand each other. And so, my friend, our journey with the Mars Climate Orbiter comes to a gentle end. A traveler who sailed for nearly a year, crossing the gulf between worlds, only to vanish because of a detail as small as the difference between pounds and newtons. If your eyes are growing heavy now, let the story settle into you like a soft blanket. A reminder that even our mistakes can become lanterns for the journeys ahead. If you'd like to drift with me again through other gentle stories of human missteps, you can subscribe and join me for the next chapter of the Great Blunders. For now, rest well, let your dreams find their perfect orbit, and may tomorrow's course corrections be light, steady, and sure.